Okay. So I think our first speaker, I don't know if it's ready. It's Wenyuan, yeah? Hey, Wenyuan, how are you doing?
Good. It's good to see a male women's conference.
Okay. So that's interesting that it worked out. So before Wenyuan starts, I would like to say something about Wenyuan. I know Wenyuan for many years. Actually, she's meanwhile a pillar in our security community. She started, I think she's going to talk about it herself, but she started in US. She was a professor at South Carolina University. Her background is engineering. And then she went back to China. Yeah, does it work? Here? This one? I don't know what you say. Okay, so sorry, there was a misunderstanding with the technician. So Wenyuan does very cool things with her group which is a very big group in China, in Hangzhou, a beautiful place, and I recommend everyone to go there. I will give Wenyuan's mobile phone number to everyone who wants to talk to Wenyuan. So Wenyuan does a lot of hacking in systems. She has a number of very innovative papers at top conferences. And today she's going to enlighten us about this path between what is she's doing. I assume, I don't know the exact content, but I assume that she's going to talk about her work in different stages of her research. And I will give the stage to Wenyuan. Wenyuan, please go on.
Thanks for the introduction. So I just shared my screen. Just want to make sure that it's the right screen. Is that the full screen or the presenter mode?
No, that's full screen. Everything is okay, at least on my screen.
Okay,
yeah.
Great. Yeah, thanks for the introduction. So I'm really glad to be part of the High Tech Women's Conference, although I can only attend online, but it's still, I can feel the room full of energy. So today I'd like to talk about the AIoT security. So the top title is From Simple Attacks to Ample Attacks when AI meets the IoT. So I summarize some of the work we've done recently and also other people's work. And so Ahmad asked me to say something about my experience. I don't have a slide for it, but yes, I got my undergraduate degree and master degree in China. Then about 20 years ago, I went to the US and applied for the PhD program, and I got my PhD at Rutgers University. After that, I joined University of South Carolina as an assistant professor. So it's actually starting from my tenure position in South Carolina before I start to work on a lot of the attacking or security analysis of commercial product. So the reason why I do a lot of that work is at the time I purchased a new car, the car has fancy feature, and I ask myself, okay, is this car secure? So that starts a lot of the project later on. So basically, I'm trying to improve the security of the products that we're using now and maybe in the future. So that was the motivation. And then about 8 years ago, I relocated and moved back to China. So there's culture differences in academia and also in life. So I've done a little bit adjusting between two countries, and maybe I can talk that later. So for now, I'd like to share with you some of the work I've done. So I'm gonna talk first what is AIoT, and then I'll talk about simple attacks. I'm gonna use a few case studies, and then I'm gonna talk about the ample attacks. So hopefully at the end of this talk, you can get some feeling on how to improve the security of IoT devices. So looking back to history, so the computing history has more than 60 years. So about 60 years ago, we're still using the mainframe computer. They're huge. Typically, one computer occupied the whole room, and the computational speed is much less than our cell phone these days. So we've gone through a long way. So in the past 60 years, it's about every 10 years we experience some breakthrough or some great improvement. We have experienced mini computer. The name is mini computer, but they're actually not small. And then going through the personal computer, we have the internet booming, and then we have the mobile phone. So in 2007, Apple have their first generation of iPhone that starts the mobile internet trend. And then in the past 5 years, Internet of Things, smart speakers, smart everything is everywhere. And with the booming of AI technology, AI and IoT, they kind of combine together. So if we look at the number of connected devices, especially those devices that are connected wirelessly, they're IoT devices, the growing rate for these numbers is about more than 20%. So in the future, in maybe 4 years, on average, everyone on the earth is going to have more than one devices with them. So now, what do these devices look like? Well, I borrowed this slide from Ahmad. So Ahmad is very good at finding interesting smart products. And this is, well, as you can see, with this smart toilet, you can have some silent competition going on in your company. All right, it records everything and it can give you ranking. And there's other smart product. Are they meaningful? Maybe someone will buy this beat widder, which will send out the last message that person ever gonna send when his or her heartbeat gonna stops. Well, as women, I guess we probably like this product better. To keep us fit, we have this smart spoon. It's been recorded to seem like the slower you eat, the less likely you're gonna gain weight. So probably motivated by this idea. So this smart spoon gonna force you to slow down by having different size of holes on the bottom of the spoon. If you eat too fast, the hole gonna be bigger. Well, I don't know whether the company is still alive, whether people still buy it. And I guess this is one of the interesting product. It's a Christmas ornament. And so basically it's a photo LED. So you can have one click to change the picture of your, the others, right? Very convenient. So you don't have to print out the photo again if your partner changed this year from next year. Okay. Wow, these are just a few smart devices that's crazy that may not be really useful, but there are actually a lot of useful products, IoT devices out there. So if we look at the difference between internet and the IoT devices, in 10 years ago, the internet is connecting people, and we're basically human is connecting into this virtual world where information cycling around. Now, in the Internet of Things, Aaron, we're actually connecting everything. Although in the end, we're still serving people. But this time, the IoT network is connecting the physical world. So we're connecting things. In the end, all these connection and these things are serving us as a human being. So now the question is, what is AIoT? With IoT, we're probably gonna have sensors sensing the environment, and then we control the environment. For instance, we adjust the temperature, humidity, or the brightness in a home. But at the time of AIoT, we utilize a lot of the artificial intelligence computing technology to do things more than just simply increase the temperature. So we have the voice assistant takes voice command. And so we have the speech recognition system gonna interpret voice and convert it into text. We have face recognition, fingerprint recognition. We have the autonomous vehicle, etc. They all have this AI feature. So as you may know that these AIoT has been used widely in our home, in the consumer market. We have smart home, we have autonomous vehicle. It can be used in the smart industry. So we have smart manufacturing and smart agriculture, etc. And also there's smart city. And so hopefully in the future, the city can sense itself, and there's may be little chance there's going to be traffic jam, and maybe the whole city gonna use a lot of additional tool to guide people to go around, to maybe guide people to stay at home at certain time to make our life easier. Anyhow, so it seems like AIoT give us a bright future. We're gonna have a more efficient, more convenient future. But meanwhile, well, as our research in security, we always hear these scary stories, some security incident. So some of you may know that there's virus like Stuxnet. They happened more than 10 years ago. They're designed especially to delay the nuclear facility in Iran. And so with this Stuxnet, the virus actually changed the program inside the PLC, programmable logical controller. And then the controller controls centrifuge. And then the way how it controlled the centrifuge actually shortened the lifespan of this centrifuge. And there's also black energy. It's a virus that can cause the power grid to be out of power. And there is Mirai botnet. It caused the whole US to have this internet service disrupted for a long time. We heard about ransom. That caused the oil price going up, and people cannot get gasoline easily. There's just tons of security incidents. So now there are so many different types of incident, and they're attacking so many different types of systems. And so then as a researcher, we ask, is there a way we can, what's so special about IoT? So is there a way we can somehow improve the security of this system? So when we use our face to unlock iPhone, can we trust it? So how do we do it? Now, we've done a short survey. So we look at the topics of IoT security, and it seems like the name of these topic, they're just, they're different types. There's no clear categories. So some of them list the area by the application. For instance, autonomous vehicle or smart home. Some of them listed as the vulnerability type. So for instance, they look at the IoT platform vulnerabilities or sensor vulnerability, etc. So now with this, we know IoT security are complex and they're coupled, but still we're trying to figure out what's so special about the security of IoT, and what we're going to, how we're gonna do the research. So this is what we come up with. So we first look at how the IoT, AIoT devices work. First, each device is gonna be placed in a physical world. And each device is gonna have at least 3 parts. They have sensors, perception algorithm, and they have controller or actuator. So typically, the device is gonna sense the physical world by capturing or by measuring these physical signals. Now, sensors gonna get these physical signals and then convert these analog signals into digital signal, and then convert into maybe some digital measurement. Then the perception algorithm gonna use the AI algorithm, deep learning or something else to have the output. So, and then give the output, give the what it perceive to this controller. Then based on the controlling decision, the controller actuator gonna send out either command or some controlling signal to change the physical world. So it could be as small as changing the temperature, turn on the heater, or it can be more complicated, driving the car. So in total, we can say for each AIoT devices, it's gonna have three components: sensing, perception, decision, and execution. Now, let me give you an example. So for instance, with a voice assistant, the sensing part is done by microphone. And the microphone gonna record the human voice, the voice vibration, and then convert into a digital voice clips. And then the speech recognition system gonna extract the text in the signal and then send it to the execution part. So based on the command, the smart speaker may open the door or make phone calls. Now, given another example, autonomous vehicle, we have a lot of sensor. They're sensing the environment, and they can capture the picture. You can use LiDAR to get the 3D scan of the environment, or there's ultrasonic sensors. In the end, all these signals will be sent into this object detection system. And then the output, whether there is object or not, will be an input to the decision, the driving decision component, and then it will decide whether I should keep my speed, slow down, or make turns, etc. So this is a very typical workflow of these devices. Now, in this process, what are the main different things of the IoT devices than internet? So we think there are two main features. The first one, we call it sensing and control in the loop. And the second part is AI-enabled technology. That's done in the perception part. So now the simple attack, it's simple. It's basically looking at either the vulnerability in the AI algorithm or looking at the sensor part. So the sensor vulnerability. So it's just checking each component one by one and see what we can utilize, exploit to causing the whole system to malfunction. So now I'm gonna give you a few examples on the simple attacks, especially focusing on the first part, that sensing and control in the loop. So how do we, when there's a sensors and actuator in the loop, what can go wrong? Now, first, briefly talk about sensors. Sensors are everywhere. So in a car, there's over maybe more than 100 sensors. With smartphone, we already have 30 plus sensors. Now, with all these sensors, so for instance, with one autonomous vehicle, we have LiDAR camera, radar, GPS, and etc. All these sensors, they work together. They may have different objects. So for instance, LiDAR and camera, they're measuring different signals, but together they're gonna help the driving decision to be made properly. So now talking about a simple attack against sensors. So the first question is, how will a system behave when sensors go wrong? So you probably heard a lot of accident about Tesla. The first one happened in 2016, and later there's a few more follows. So the reason why these accidents happen is because the sensor failed to detect there's an object ahead of it. So we actually so before the first incident happened, we have analyzed the sensors, the object detection sensors on Tesla for 3 sensors we have analyzed, and we actually found problems with these sensors. So what I show here is actually the video we're analyzing the ultrasonic sensor. Sometimes we call it parking sensors. So we can actually hide objects by having interference, by not touching the car, but just sending out signals. So let me show you the video. So this white car is Tesla. And right now, we're not starting the interference. And we're using the remote to ask the car to go backward. Now, the car at the time having the proper sensor. So the sensor is working properly. So the ultrasonic sensor knows there's a human behind. Now we turn on our interferer. Now the bar behind my student is actually interference. Now we use the remote to reboot the Tesla. And then this time, because there's interference, and so the car sensor can no longer detect there's a human behind it. Well, by the way, this student was not part of the project, so he didn't know what's going to happen. He told me he was scared when the car moved backward. Anyhow, he has graduated safely. So when we do experiment, we care student very much. So this is just one small incident. Okay, so just a few more points on this. So we noticed that the reason why these ultrasonic sensors on Tesla cannot detect the object behind it is because this sensor has some smartness. So we purchased cheaper similar sensors. We cannot actually kind of attack it. Just because the sensor is smart, it's using some dynamic adjustment algorithm to adjust the threshold of the detection algorithm. So we're able to hide object. So this is just an example showing that the designer should really think from adversary point of view and don't just add smartness into the system without consider whether this is going to bring problems. So we've done other sensors. So for instance, this is an thermocouple. And then the display of this thermocouple is negative 1,409 Fahrenheit. Well, in the lab, we have no way to be able to produce such a low temperature. What happened is we use this green antenna to send out RF signal, radio signal, which cause the sensor to malfunction. So sensor is basically a proxy of reality. And then it has some assumption on how to interpret the measured physical signal, but they just don't, they have a lot of assumptions, just let me put it this way. So now there are different type of sensors. You may ask, okay, so for different sensor, things may go wrong, sounds like very chaotic ad hoc. So how can we do research analyzing sensors a little bit more systematic? So now let's look at what's inside sensor. So in fact, these type of attacks that let sensor measure not the reality, but output measurement that we ask it to do. This type of attack can be called as transductive attack. And we all send a signal to change the sensor output. So if we look at what's inside the sensor, each sensor has a transducer in it. So basically this transducer gonna convert different type of energies or different types of signals into electrical signal. So for instance, microphone convert mechanical signal into electrical. And then thermocouple convert a thermal signal into electric. So there's a 13 type of transducer. And this is piezoelectric transducer, which basically convert between pressure or strain into voltages. And meanwhile, for each sensor, after transducer, there's amplifier, filter, analog to digital converter, etc. So we can consider each sensor, each blue box, as a transfer function, which takes some input and then generate output. So in the regular case, we have legitimate input and the sensor is supposed to produce output. But when we have malicious input, the output of the sensor is actually the combined effect of both the good one and the malicious one. Now, what type of signals can be malicious one? And so if you're interested, we have one SLK paper on how to systemize this analysis. So what type of malicious signals can be? So the signal can be the radio signal, IF. It can be acoustic signal, can be light, magnet, and heat. So with all these signals, you don't have to have physical access to the sensor of your devices. You just send signal, and then the output of the sensor may be affected. So I'm going to talk about the first three types: the IF, the acoustic, and the light. So very briefly, first let's look at acoustic attacks. So the first dolphin attack, the first example is using voice assistant. Typically, voice assistant is supposed to use microphone to record audible voice command. But in this example, we discovered that the microphone has some nonlinearity vulnerability. So in the end, we're able to just inject silent command, or the command that's modulated onto ultrasonic ultrasound band. So human cannot hear it, but the devices, your phone or your smart speaker will hear it. So you can, someone close by to your phone can control your voice assistant. Now, with similar idea, someone also proposed, maybe we can use this attack in a good way. So on the right, you see this lady has a ultrasonic speakers bracelet. So basically, this bracelet is sending out ultrasound signal, and these ultrasound signal can jam all the recording devices close by. So with this bracelet, you can somehow protect your private conversation. Even someone want to record it, what they recorded can be the white noise. So this is one example. Now, let me show you one more example. The example is against accelerometers. So accelerometers are used almost everywhere, in pacemaker, in your phone, in the hard drive, and also in the car to trigger the airbag. So typically, the accelerometer are done with MEMS structure. MEMS is micro electrical mechanical system. So on this picture, you see inside this MEMS sensor, there's this blue electrode. One is positive, the other is negative. The positive one is fixed, but the negative one has a sensing mass attached to it. And the sensing mass is somehow like attached to the shell of the sensor with a spring. So when the accelerometers are moved, are exposed with force, then the sensing mass, the negative part, gonna move. Once the distance between the positive and the negative electrode moves, then the capacitance change. As a result, we can measure the capacitance change and then output the electrical signal. So this is how acceleration is measured. Now, with the electromagnetic structure, so MEMS structure, we know that there is this what called resonant frequency. So now if we play the sound, the voice, at the frequency that hits the resonant frequency, then what happens is that the output of this accelerometer gonna be the combination of acceleration and sound. So as a result, so there are a few work. The first work is published in 2015. They're attacking in UAV, so drone. So with drone, we know drone has a lot of gyroscope to measure its own position. Now gyroscope is very similar, has similar structure as accelerometers. So when there's a speaker plays huge sound and the sound's frequency hits the resonant frequency, then the output of this gyroscope no longer reflects the real position of the drone. So the control algorithm will always output the controlling policy that doesn't fit the drone. So that's why the drone will not be able to fly smoothly as it's supposed to, but will drop. So this is actually what the video shows. This is a DOS attack. We can actually do a fine-tune attack, which means we can have the accelerometer to output value that we want. So as you see on this plot, we actually analyze and attack two types of accelerometers that's used in Fitbits and smartphones. So we let the output of this plot show as a word, English word, walnut. And the paper name is actually also walnut. So let me just show you in this video. So you can see on the computer screen, we try to produce walnut, and the sound is played by the phone. Oops. Let me see whether I can play it. So we hide a high-pitched tone in the music. But you can see whenever there's high-pitched tone, we have the walnut. So what else fun thing we can do? Well, we also played song to a Fitbit. And so in 20 hours, I don't know how many steps you can walk every day. So within 20 hours, the stationary Fitbit managed to believe it has 80,000 steps per day. And also with sound, we can also affect hard drive and eventually cause the computer to have blue screen, actually have black screen in this case. Just let me show you. So here we have the ultrasonic transducer hitting here, and then we're doing a big file copy. When we start the attack, so the throughput drops. And then after a while, the computer will run into this black screen, actually. So you may ask, what happened? What happened is that inside a hard drive, the hard drive wants to protect itself. So whenever a hard drive is in a free dropping mode or is in a high vibration, the hard drive gonna stop read and write. So we use the ultrasound to make the sensor inside the hard drive to believe it's having a huge vibration. And then the hard drive will stop read and write. The operating system doesn't know there's such type of attacks. So the operating system actually panic. And it report smart failure predicted on hard drive. It think your hard drive is broken and you need to back up your data. Okay. We also did video surveillance. So in this case, we're attacking one video surveillance system where the videos are outstreamed to a hard drive. We're using similar method. We'll see, although the clock is ticking, but there is one jump. So basically from 11 seconds to 1 minute and 31 seconds, there's 80 seconds of video missing. So the modern thief, if they read our paper, they can carry a high speaker and then to prevent the surveillance system from recording them. So there's no log will record as an attack. It's just everything is pure physical. Okay, so now we're also doing work on the microphone using optical signals. So this is actually the work done by Michigan University. In this case, the attack is against smart speaker, but we're using light as the malicious signal. So when lights hit the microphone's diaphragm, it's gonna cause vibration. So it has this photoacoustic effect. And then the researcher managed to beam one laser into a smart speaker that sits right next to a window. It's about 100 feet away, and ask the smart speaker to open the garage door. Okay, so I didn't have a video on it. We also have optical attack to blind the camera, and also use laser to fool the LiDAR to create ghost image or to hide object. So we look at the IF signals. So very briefly, we managed to use the radio to inject for signal. So we can actually use radio to inject voice you cannot hear from the environment into the recording devices. We call it ghost talk because the recording, the voice recorder managed to record something that's not hearable by human. We also managed to inject heartbeat signal into pacemaker while the pacemaker is not installed on human at all. Okay, so just give you a few examples on the attacks on sensors. Now, very briefly, there's a lot of work on attacking AI algorithm, right? So for instance, with computer vision, doing object detection, typically we have this sequence. We have a sensor taking pictures of an environment, and then we have the algorithm decide what's in the picture and then make decisions. So there's a lot of work looking at the what we call adversary example, basically fool the AI algorithm to output the wrong classification result. So there are two types of attack. If we look at where the attack happened, a lot of it is digital attacks, where the attacker either add noises to the digital photo, digital image, or add something during the training phase. There's also physical attacks where people put physical perturbation, put tapes on the stop sign, for instance, or 3D print out stuff to fool the AI algorithm. So for instance, the digital attacks can include the
4 minutes.
Oh, 4 minutes? Okay.
Yes.
So then let me just quickly go through this. So you probably are very familiar with all these. With physical attacks, you basically print stuff, 3D glasses, and causing the detection algorithm to be to output the face recognition result will be not you, but someone else. So these are all the simple attacks. So with 4 minutes, I'd like to show you about ample attacks. With ample attacks, we're looking at the sensor vulnerability and the AI algorithm vulnerability at the same time. So during for an autonomous vehicle, we don't have to put tapes on the stop sign to causing the car to believe this is not a stop sign, this is speed limit 75. So with this, we can add physical perturbation into the physical world. So why it's called ample attack? It's because we're trying to injecting physics into adversary machine learning. So here's how it works. The same thing, we have computer vision system with autonomous vehicle. During the sensing part, we are sending signal to cause the camera to sense or output images that's not really the environment, and then causing the perception algorithm to malfunction, and then causing the bad driving decision. So the whole thing is that we're attacking the sensor. So here's how it works. We call this attack poltergeist. So first of all, with camera, especially camera on a car, it has this what we call OIS system. So basically, when the car is driving, it has a vibration. So in order to prevent the car's camera to taking blurred picture, the sensor gonna sense the movement of the camera and do some blur kind of image stabilization. So blur compensation. So now, and then the image in normal case should be clear after the blur compensation. And then we get the correct output from the object detection algorithm. But we've talked about so many sensor vulnerabilities. So think about if we use sound to affect these sensors, to make this sensor believe they're in high speed vibration. And then the CMOS sensor going to do some unnecessary compensation. So the picture should be clear, but it done something unnecessary and causing a blurred image. And the object detection algorithm actually don't know how to deal with it. So the output will be different. So let me just show you a few results. We managed to hide object. As you can see, from left to right, we increase the level of attack. And then we can create stuff that's not there. So we create a person. We create a car actually, and we can also change the object from A to B. Let me just show you videos. So we've done this in real world. We've done this in a car, and we use two smartphones to record what's up front. And the left one is the ground truth, and the right one is the ultrasonic, is the one that's under attack. We use sound. So this is what I achieved. So we managed to hide cars. If you look at the right, so we're creating a trunk. So this is the second case. And then for the third case, we're converting a car into a person. Okay. So basically, this is the ample attack. Now, okay. So I'm gonna quickly. So far I talked a lot of attacks, and in fact, for each of the attacks is just the first step of security analysis. We have solutions. Since most of the time solutions are straightforward, so I didn't talk about it. And then I just want to talk a little bit about the conclusion. So hopefully from this talk, what you can get is there's risk from the analog signals, regardless whether it's RF, radio, or acoustic, or light. They can change the sensors transducing stage. And there's actually solutions for sensor vulnerabilities. So first of all, we should stop trust sensor blindly. So far, your operating system and everything, they believe the sensor always work properly, but that's not the case. Then maybe we should redesign the IC of the sensors, and then make some hardware software combined API. So the sensor can give you some output and will tell you how confident it is. There's also solutions for AI vulnerability. And then in the end, I think testing is very important. So maybe we should consider how to fuzz sensor, especially system with sensor extensively, so that we can avoid incident like the crash of plane and etc. So with that, I just like to acknowledge this is some of this is our the authors of the works that I've talked in this paper, and some of them are my student, and some of them are Kevin's student. So far, the lab I have is called USS Lab, Ubiquitous System Security Lab, and we have this is actually the picture from last year. And this year, we growed a little bit. So if you're interested, we are hiring people from embedded system security. So this is ad time, commercial time. If you're interested, you can go to our lab page to see other works. Okay, thank you. That's it.
Okay, thank you. Is that on? Is that on? Okay. So thanks a lot, Wenyuan. You smartly misused this event for your advertisement. Thank you very much. So it was a very wide range of topics. And as you showed the picture, I was in that institute, and Wenyuan has an army of students. Some of them are really, really good students. And she's going to be a very, very powerful person in China. I am. And so if you want to just get hired by Wenyuan, first talk to me. Yeah, sometime doing training at my place and then coming to you. Okay. So now, is there any questions? You know, it is still for academic standards early here. So
Yeah.
I think, yeah, please ask a question. We have a microphone, and there is a microphone boy. He's coming. Okay. Mike boy. Yeah.
Hello? Hello,
Okay, hello, can you hear
hello?
me?
No.
You did you turn it on? There is a button.
Okay, can you guys hear me?
Yes, I can.
Okay, perfect.
Hello?
So,
Hello?
hello everyone. My name is Mihai Moldovan. I'm watching remotely from Romania. My question would be regarding sensors. Since we know they are the source of ground truths, shouldn't we actually focus on technology used for manufacturing those sensors instead of trying to patch all the issues?
So it's the remedy, right? How can we change the status? Actually, some of the defense, ideally, we should redesign our sensors and make all these sensors perfect. But in reality, it's hard. So for instance, with a microphone, the reason why we can inject ultrasonic command is because of the nonlinearity of the microphone. And I talked with the sensor designer. They told me that the reason why there's nonlinearity is because of the volume, the size of this microphone. You want to have your phone small, and you don't want to have a microphone that's as big as your finger. So that's why you can't just redesign the sensor without these vulnerability. But what we can do is we can use software to detect these problems. So kind of can get a benefit of the size and the volume and the security. So there are a lot of constraints when we design sensors. And so in real life, we just have to sometimes live with the sensor problem.
So
Okay,
the next
thank you
question
very
comes. Oh, sorry. Thank you. The next question comes from. Please identify yourself.
Hello, my name is Parisa. I'm from Radboud University. So my question is probably a really detailed question about the stabilizer that you had in the core system. So basically, I imagine that the sensor probably has a small unit for some kind of calculation to stabilize the image, right? So I was wondering, what is the cost function at the end that calculates the probably something that shows that the image is blurred or not? Is it something simple that, because if it's like calculating the edges and these kind of things, probably if you put the sound, inject the sound to the sensor, still the algorithm should identify the blurry images at the end. So it increased the cost function instead of decreasing it at the end. So I was wondering if these kind of sensors has a small kind of processor or something that they cannot put like really sophisticated algorithm to detect these kind of things, or it's just, I don't know. I mean, probably there is pre-processing steps there. So I was wondering about the algorithm that does this, that stabilizing.
So, okay, so the reason why our attack is possible is because this was not considered before. There's actually a blur detection algorithm. You can do that to first process your image, and then there's the blur algorithm as well. So before the computer vision part to do the object detection, if there's a deblur stage, then our attack will be very hard to be successful. So it's more like, to answer your question, I think what you propose is doable, but the system need to have that to do it. Did that answer your question?
So the stabilizer itself doesn't do much, right? The sensor itself. Okay.
No, the stabilizer basically.
It is now destabilized. Okay, so we keep Wenyuan frozen, and so Wenyuan is out or is in. So is there, if there are other questions, I would say you just send it over if you have this, I think we have the chat functionality, or you just send an email to Wenyuan. Wenyuan, if you are hearing us somewhere in universe, please come back.